This week on Cloud Slaw, we're going to dig up the body and get started on the forensics. Solving crimes is hard work. With a little grit and a strong stomach, we can all get through this together. Work with me, people. It's like a Friday afternoon after work, and I can't go to happy hour until I finish this up. All right. Last week, we learned about elastic block store volumes and snapshots. We launched an instance via CloudFormation, identified the storage volume, created the snapshot, and then shared that snapshot with our security audit account, which, as a reminder, is filling in for like a true forensics analysis account. Now, this is such a standard process. It's part of the very first cloud security automation code I ever wrote. Code that's so old, I coded it in Ruby, and I'm a little embarrassed about the whole thing, although it did eventually do founding and successfully exiting a startup. Anyway, as a reminder, we call this process forensics acquisition, and our objective is to obtain a forensically valid copy of the data. In other words, we can prove the source has not been modified or tampered with. Now, that isn't all that important on most cases, but if you ever have to investigate something that might end up in court, and this includes human resource kind of investigations, not just outside attacks, it's a really good practice to keep your original sources, your forensically valid sources of evidence. In a larger environment, you might do this a lot, and it helps to have a standard setup. Here's a slide that I actually use an example architecture from my incident response class that's really similar to what we're doing. This shows the split between monitoring. In our case, it's that log archive account, and then our response account. And I've kind of mixed and matched a little bit here. We're using our security audit account to do the forensic analysis. Some places you might run this on the security operations account. Your responders will log into the analysis environment, and then they're going to pull that data from the target environment. And that's pretty much how we set things up last week and how we're going to do our analysis today. We already took the snapshot directly in that environment, and we shared that with our security audit account where we will perform our analysis. The way we're going to do that this week is we're going to create a new EBS volume from a snapshot. And that's the core skill I want you to learn. And we're doing an operations thing, but with a bit of a security twist to it, where they're going to attach that volume as an additional drive onto an analysis system. And we're going to learn how to access that drive and explore what's on it. Now, if you've ever worked in a cyber forensics lab, you would have all sorts of special hardware to actually copy physical hard drives and connect to them without modifying what's on the drive, so you have that original evidence. In the cloud, we just get to run an instance and connect to storage volume. The snapshot is immutable. You can't actually change it, so there's no way to mess up that core snapshot, although you do have to make sure nobody deletes it. And that's a great way for us to go ahead and preserve evidence and keep the lawyers happy. In a real enterprise environment, a SecOps team would have some pre-configured images, AMIs, set up with their analysis tools already loaded on them for different operating systems. In our case, we're just going to use a regular Amazon Linux image, and we're just going to poke around using some, basic poking around directory skills to see if you can find anything interesting in that compromised instance. And yes, I did plant something hopefully interesting in there for you. So the key points today that I want you to get out of this lesson. The first and the most important is that you can preload new storage volumes by creating them based on a snapshot and then attach those as second drives. This never changes the snapshot. Even if somebody modifies that storage volume and say deletes all the evidence, you still have that snapshot that you can always create a new volume from. So this is a really important capability for backing up, for resiliency, and for sharing data. We're going to use it today in a forensic analysis situation. This analysis also should be performed in a different account than where the incident happened, because you don't know if the attacker is still hiding in that account. Kind of like, I don't know, apparently China is hiding in the US federal wiretap system. We'll see, how long that statement lasts for, or how many years I'll get out of that bad joke in poor taste. But anyway, you do have to worry about attackers still being in that environment, or even just a developer or an admin accidentally deleting something. So that's why you always want to get a copy of that into a different environment. Now we're skipping a little bit there because technically we're going to copy that snapshot locally. In our case, we're just going to do the basic analysis portions of it. All right, starting rambling on a little bit. Let's go ahead and let's jump into the lab. From the sign-in portal, we're going to go to not test account 1. That's where our fake compromise instance was. We took the snapshot and we shared that with security audit. So let's go to security audit under administrator access. I think security full admin would work as well, but I'm being lazy and I don't feel like checking. Once we're logged in, we go to cloud formation as we've been doing every week, create stack, and paste in this week's template, lab42.template with the same opening, and click next. No, oh, we have to give it a name. Let's call this one forensics and click next. Now remember, in a real enterprise environment, you would have your forensics environment built out already. You wouldn't be building it on the fly like we're doing here. But this is just one of those contrivances we use for our labs. All right, create is in progress, and I'm going to go ahead and pause the video as usual until this finishes up. Everything is up and running, and let's go over to EC2 where we'll do all of our work. Now, once we're in EC2, the first thing we want to do is go to snapshots. And you'll see by default, you probably see all of these public snapshots. I think that goes to the heat death of the universe if you trace it down, or the Big Bang. It's one end or the other, but there's a lot of them there. That's all right. You can filter down to the ones only in your account, and we don't, have any in this account, or private snapshots. And these are the ones shared privately with this account. We have the CSI incident one that we did in our prior lab. And that's our compromised instance. I mean, not really, fake compromise, yada, yada, yada. Anyway, and if we click on that, we can then go to see the information about it. You can see what account it originated from and its description. And here's where the work starts. So we're going to go to actions and create a volume from the snapshot. Now you can create a volume and define everything first and then load the snapshot into it. That's all part of the process. This, if you're going through the console, is my recommended path. So we're basically going to create a virtual hard drive and we're going to load it up with all the data from the snapshot. And if you go this way, it just defaults all of these to the correct things. So the right volume type and the right size, and it just shortcuts. Now, important thing is you have to be in the same availability zone as your instance. Now, we didn't check because I know, because we used CloudFormation, that we deployed into 2 alpha, but you would need to check in a real situation to make sure that that availability zone is where your instance is in. Because basically what we're doing here is we have our snapshot, which is our copy. We have our EBS volume that we're about to create, which is our virtual hard drive. So we're loading the snapshot data into this virtual hard drive. Then we're going to plug that virtual hard drive into a virtual machine. And you can't do those across availability zones. They need to be in the same availability zone. It's just like a limitation of the hardware, and it's totally reasonable because honestly, those things need to have like real high-speed networks connecting them together. Okay, back into the console, and we're not going to bother with encryption or anything. One thing we do want to add is a tag because it really is very easy to get lost with these snapshots and with these volumes. We're going to do a name tag with a capital N. And if you do that, it's going to show up in the console. And then we're going to give it the name CSI to keep track of it. And scroll down, create volume. With a smaller snapshot like this is pretty quick, 8 gigs. And snapshot, oh, nope, we need to actually look at volumes. So let's go to volumes. And within volumes, you see we have our CSI volume. And I'm going to click that checkbox there. And you can see that it's already available. It's all set, up and running. What we want to do is now we need to plug that in. So we're going to go to Actions, and we're going to attach the volume. Now the instance, you might have to do research if you're in a big environment, but in our case, we only have the one running. Makes it nice and easy. The device name we want to choose for our purposes is /dev/SDF. And you could put it in at different locations. This one I know works, and it's also one that I've used in lots of other labs over time. And I don't want to go into the details of why I pick SDF versus SDB. One thing to understand is we're mounting it at SDF. I think that stands for SCSI device F. But internally, newer Linux kernels may, by may they mean will, rename it to XVDF. So, and by the way, I think anything earlier than F is often reserved, which is why we're starting at F. So that's going to be renamed. It's going to make a whole lot of sense. And I'm going to show you what that looks like once we get into the instance attach volume. Okay, so that's created. It is in the process of attaching. And you see, there it's attaching. And I bet you if I refresh, it's already attached. So that hard drive is plugged in. Now we need to go to the operating system and we need to do a few command lines so that we can look at it. Ignore all my little test ones here. And yeah, believe it or not, don't get these labs right the first time, all the time. Let's click on forensics and we're going to go to connect. And using session manager as usual, we're connected in. I'm going to make my screen a little bit bigger just to make it easier for you to see it, the text, because we have to do some command lines. Now, the first one is just kind of more to show you what's going on, and that's LS for list and BLK, all the block devices that are connected. So that's the storage volumes. And you can see here there's two. So we have one block device connected and it has 3 partitions. And this is the actual boot volume. And that's how I know, because it says boot. The next one is the one we just attached. Remember, we attached it to SDF. It shows up as XVDF. It turns out it also has multiple partitions. Why? Because it used to be a boot volume. It's a snapshot of a boot volume. So that's why we have all of the, that's why it looks the same as the one above it. Well, with that in place, we need to have a place to kind of hook in this drive and mount it in the operating system. So the first thing we need to do is sudo, which stands for super user do or escalating our privileges. Don't call it sudo. That just sounds weird. It's sudo. Sudo make a directory, and let's call it /forensics, which means it's going to create a forensics directory at the root of the entire file system for this instance. I know that's sloppy, but I'm a hacker, so everything I do is sloppy. Next, we're going to go sudo, and you know what? For this one, I'm going to copy and paste it so I don't make a mistake. Okay, because we're mounting this drive that has multiple partitions, we only want to mount that one partition, and we just have to make sure it's set up to use the right file system. That's some Linuxy stuff. I don't want to go into the details on it, but it's pretty easy to find that if you do this on a regular basis. And we're going to mount that drive at /forensics. Hit enter. All right, that's all set. So I'm going to give you a couple of basic Linux commands to poke around, and we're going to see if you can find anything interesting here. So if I go to cd/forensics, which is change directory to forensics, and then do ls, that's going to show me all of the various directories. And if you search around those, cd, for example, /dev, which is those devices, and ls, you're going to see all sorts of stuff. cd space ... All right, here's the deal. I'm not going to give you the answer. I'm going to say it's pretty straightforward to find this. And I don't know, maybe if you poke around like home directories and stuff, you might see something. I hate to spoil it. I know, but some of you aren't Linux people, so I got to give you at least a couple of hints there. Hopefully you find it interesting. Feel free to drop me a line if you don't, and I'll just go ahead and give you the answer. Just go ahead and email me. Not a big deal at all. And so the key points for what we did here is we did a little bit of a lightweight of how you would actually do disk forensics, but we did it in a way that was designed to show you some fundamental skills in AWS. And that was how to take a snapshot. We talked about what snapshots and volumes were, how to share that across accounts, and then how to go into the other account, create a storage volume from that snapshot, attach it to an instance, to a virtual machine, and then see what's running inside of it. Really fundamental, really good skills to have. This is one of the ones that we do all the time if you actually have to do any analysis yourself for real. All right, hope you enjoyed this one, and we'll see you in a week.